Check, check, check. What's up, everybody? Welcome, welcome. We're making this happen. Model Monday late. Hope it's not too late for some of you in different countries. It's a little bit late here. See if we can get some audio adjustment. I know things are looking a little low. Want to try and get them to a good volume. Make sure everybody can hear what's going on. Let me know, as always, in the chat how things are going from an audio perspective. We got some people here today. Figured it would be a little bit light tonight, but that's okay. We got Bob Phelps here from Iowa. What's up? What's up? Jern is here. Chris Knudsen is here. Welcome, welcome. The true OGs. This very special episode of Model Monday late. I didn't want to skip 2 weeks in a row. I knew I would be out last week, and I wanted to make sure that we didn't go too long without having a consecutive episode. I know that it's important, you know? We got to make sure that we keep giving you guys your practice, giving you your live CAD versus CAD competition fix. I know that we've got the Practice Models app up, and it is cooking, and we are putting out lots of content on that Practice Models app, but sometimes, you know, you just got to get live with other people. You got to do the head-to-head CAD versus CAD competitions, and sometimes I know you guys get a little thirsty for some new stuff. So here we are at the end of this long weekend here in the States. CAD versus CAD action is still alive and kicking on this very special Model Monday late. I should probably do Model Monday early to catch the Euros and the people in India. But then as we get into like Australia, our friends in Australia, you know, it's a little too early or a little too late. So let's get into it here on this very special episode of Model Monday Live. Today is May 27, and we are going to be doing some CAD versus CAD competition and, of course, hanging out with the best chat ever. Don't forget to like and subscribe. A great way to support the channel is to like and subscribe. Hope everybody had a good weekend. I had a great long weekend. Got to do a lot of stuff outside. Got to hang out with friends. Got to have a really, really nice weekend. So I hope you guys all had a good weekend too. And let's get into it here with this CAD versus CAD speed modeling challenges. We're going to do two CAD versus CAD speed modeling challenges. We're going to do a live solve using SolidWorks. We're going to mix it up a little bit this week. Since we've been doing all Onshape for the past few weeks, we're going to mix it up and do some stuff with SolidWorks this week. And we are going to hang out with the best chat ever. I'm actually looking for the chat right now. I lost the chat. I lost you guys. I lost the chat. Jordan says, happy to be home after a long 6-day power outage. Oh boy, that's not good. Don't like the sound of that too much. 6-day power outage. What is that all about? Wow. Yeah, I don't think that does not sound good at all. Well, I'm glad that you're back just in time for some live CAD versus CAD competition. Houston. Yeah. Okay. Well, that's a good explanation. All right, let's do it here. We're going to do a live solve using SolidWorks. Whoops, that's a lie. There should be a live solve using SolidWorks. We're going to solve that model. And, of course, we're going to do our live challenges. If you're here for the first time, let us know in the chat. And there are lots of chat pros who will help you out and answer any questions that you have. But what we're going to do tonight is I'm going to show you a 2D print and challenge you to turn that into a 3D model to calculate the mass and to enter that mass directly into the YouTube chat. And the fastest person to do this will be declared the winner of the point. Final points are up for grabs right now for the month of May. And then we will move into June, and we'll talk all about what's happening in June here in just a moment. But the basic rules are that you can use any 3D CAD package. As long as you can input the density and output the mass, you can use any 3D CAD package. And make sure you use the specified precision on these answers, and the first correct answer in the chat will be declared the winner. The advanced rules, or the unit systems that we use here, are inches and mmgs, inch pound second and mmgs. The materials we use are listed down below. So if you are here for the first time, make sure you take a moment, make sure that you capture those materials in your materials library so that we're all working from the same materials, so that you don't get any surprises, don't get caught off guard. We want to make sure that everybody has the correct material density in their library. Otherwise, you're not going to calculate the mass correctly. And the advanced rules are, this is meant to be fun and good-spirited. Occasionally, I will make a mistake. I'm going to be honest with you guys. I didn't really properly quality check the second challenge tonight. So it's possible the second challenge is going to put you on a wild goose chase. But we'll see what happens. Maybe I'll click along with and see if we can't figure it out together. And the Ivan exploit is permitted in these challenges. So the Ivan exploit is permitted. Be on the lookout for any opportunity to use the Ivan exploit. All right, with that, let's get into this first challenge. This first challenge for all of you will begin in 3, 2, 1, go. What is the mass of this part in XXX grams? What is the mass of this part in XXX grams? What is the mass of this part in XXX grams? Kind of a cool part. It's called latch lock. This part is using 1060 aluminum alloy as the material. It's got 2,700 kilograms per cubic meter as the mass. And this part is a tier 4 part. Tier 4 indicates the complexity of the part, meaning the number of features required to make it reasonably. This probably is in between a tier 3 and a tier 4. So right on that cusp, right on that magic cusp between tier 3 and tier 4. So grab a screen capture of this print, begin modeling it. Don't forget, we've got lots more models over at TooTallToby.com/practice. Get them while they're hot. TooTallToby.com/practice. Good music tonight. I'm liking these tracks tonight. Turn this up a little bit for everyone. I like this one. All right. Give you guys some modeling music. See who can calculate that one the first. Harv Ortiz is here. Says hello from Dallas. What's up, my man? Thanks for joining us. This is your first challenge of the night. We're just showing it now. The CAD experts in the chat are trying to figure out the best way to create this model. So feel free to grab a screen capture, Harv, and you can play along with. Your goal is to calculate the mass of this part and enter that mass directly in the chat. This is our first challenge of the night. We're going to have 2 challenges tonight. This is a tier 4 part, really in between a tier 3 and a tier 4 part, right on the cusp. But we're going to call it a tier 4 part. Can you calculate the mass of this part? Let me know, guys, if the music is too loud. I'm digging these tunes, so I'm going to leave them up a little bit. All right, let's get into it here. What's the big news that's happening in the world of TooTallToby? Well, before we can talk about that news, we got to remind everybody, don't forget to support the channel. Hit the like button. That's the easiest way to support the channel. Subscribe to the channel. Another great way to support the channel. And, of course, share and reshare. Take a screen capture of what we're doing. Tell your coworkers. This week, your challenge, as you get back from that long 3-day weekend, your challenge is to walk up to one of your coworkers while he's in the middle of using a cross pen on a Excel printed out bar graph. And you say to him, hey, did you know about TooTallToby? TooTallToby.com. Check it out with your LCD monitor. Let him know. Let him know that is what's up. That's the place to be. TooTallToby.com. Tell him about the channel. Tell him about the YouTube channel, about the website, about all the apps. And, of course, if you're ever interested in supporting the channel financially, we do have avenues to do that. You can use Super Chat here in the live stream. You can use Super Thanks if you're watching the recording. And you can visit us at TooTallToby.com/donate to send in a financial contribution and try to help the channel stay alive. That's really the truth of where we are right now. Help the channel stay alive. All right, guys, what is the biggest news in the world of TooTallToby right now? The biggest news is the next CAD vs. CAD tournament is coming up. CAD vs. CAD tournament, free registration begins June 17th. Register using any 3D CAD. If you enjoy friendly, competitive CAD vs. CAD action, this is the place for you. And this is the World Championship. We're going to have 16 runners in the World Championship from all over the world. The matches are going to begin August 30th. They're going to run August, September, October, and they are going to conclude on October 18th. So join us live for this CAD vs. CAD competition. Free registration begins June 17th. You can visit us at TooTallToby.com/tournaments to learn more about the tournaments. I got to give a shout out to Bodie McBoatpants. He really did a nice job reviewing the history of the tournaments and kind of putting together a little historic record of all of the tournaments. So if you go to TooTallToby.com/tournaments, you'll see here that there is a kind of a historic record of the tournaments. There's the FAQ, and then we get here kind of starting from the most recent and working backwards. So if you go all the way down to the bottom, back in 2020, we had Ivan the Reasonable win the Summer Championship. Then we had Cam Smith win the Winter Championship. Then 2021, the World Championship with Gerbin, the Inventor user, our first Inventor user to win the tournament. First and only, really. And then we had the 2022 World Championship with 32 people. Massive tournament. Allness coming in first place in that tournament. Then we had the 2023 World Championship. We also saw Ivan the Reasonable in that tournament, and we saw him make it into the final two. We saw Allness's brother, Imants, running Onshape, making it into the final four. But Victor K emerging victorious, a SolidWorks user. And then earlier this year, we had the 2024 Spring Open, and we had Airwick, the Onshape user from Canada. So Canada has taken this thing down twice. Ivan the Reasonable and Airwick. Airwick winning the Spring Open earlier this year. So lots of good stuff there. TooTallToby.com/tournaments, but really excited to start sharing this flyer. You'll see this thing going out this week, guys. So if you see it out there in the wild on the social medias, please grab it and reshare it. Let's try and get as many people involved in this as we can. That's when it really gets exciting. We've got some serious competition on the leaderboard these past couple of months. Possibly a brand new wizard rising up again from Canada. So really, really interesting stuff here in the world of competitive 3D CAD, and that tournament is just about to start again. You guys know I love tournament season. My favorite time of year, so very excited to get back into it. We did post a nice Onshape tutorial a couple of weeks ago, so if you're an Onshape user and you haven't had a chance to check that out, check it out. It'll give you everything you need to know about Onshape, kind of start to finish, end-to-end tutorial. We also posted another video here on the TooTallToby channel this week for Onshape. So if you go to youtube.com/TooTallToby, which is really where you are right now, you'll see that another video posted this week, and that was a video on branch and merge. So here on the TooTallToby YouTube channel, the new Onshape video for branch and merge has posted. Definitely another good one to check out if you're trying to learn about Onshape. This is huge. I mean, I can't understate. I can't understate how valuable this idea of branch and merge is, especially the merge part of it. And the fact that Onshape can merge geometry together is huge. You're going to hear me talking a lot about that over the next few weeks. So definitely check out that video if you haven't had a chance. I know those videos are a little bit long, so it's more like if you're really trying to strap in and learn Onshape, they're going to be good for you. But I'll make some shorter ones that really kind of like touch off on the highlights. Okay, the World Championship is coming up. We talked about that already a little bit. And the May, I really should say the May leaderboard, because the May leaderboard is up now. The April leaderboard was really heating up, but the May leaderboard, man, we have got some epic competition showing up on the May leaderboard. If you go to TooTallToby.com/leaderboard, you'll see that you have the opportunity to do these challenges. Speed model these 3 parts. So you get these drawings, and then it's up to you to speed model these 3 parts. Well, QWERTY CA, who came in first place last month using SolidWorks, once again is just dominating and really showing some clever workflows. I encourage everybody to take a look at this video from QWERTY CA. what you're going to see when you see this video is a video that almost looks like it's sped up, but it's definitely not sped up. This is actually how fast QWERTYCA is with his commands, and a very, very clever workflow, particularly the use of the shell command, the way he does the shell command here after he gets this fillet in place. He's going to do a shell here and do a multi-thickness shell to create that geometry. I mean, that happened really fast. This is almost something we could slow down rather than speeding up. But basically what's happening here is, if you look at this shape here, let me just pause it here. If you look at this shape here, we've got a wall thickness here and a wall thickness here. And most of the time what people would do to accomplish this is they would sketch a circle and sketch a rectangle and then cut extrude down through the model. But instead, what QWERTYCA did was he did a multi-thickness shell for that feature, which just like completely blew my mind. He did that as a shell to hollow that out. I mean, it happens really fast. Like, here's the extrusion. Now he fillets, face fillet. Now he jumps into a shell, switches to multi-thickness, picks these two faces, and then you end up with this geometry. So I'm excited to do kind of like a reacts video to this run. This is a really impressive run. Definitely encourage anybody who's considering doing the leaderboard challenge to take a look at this run. But even if you're not going to do the leaderboard challenge, just take a look at TooTallToby.com/leaderboard and watch some of these runs. I mean, it's incredible. The not only the speed, but also just kind of how clever some of these features are that he's using. Like in the case of this model here, when he gets to this internal geometry, the use of the intersect command to clear this out. Like, I would have never thought to do it that way, but he's going to go through and use intersect to remove certain bodies and just kind of remove all the excess geometry from that part and then end up with the correct mass. Really, really clever use of intersect. And the cool thing about watching these runs is that, you know, you get the chance to see kind of an out-of-the-box way of thinking about using certain features, but you know, you may end up finding a good spot to use those same features in your career. You know, even if it's shown as a SolidWorks feature, you might find that there's a way to use that in Onshape. There's been plenty of times where I've seen people run stuff in Onshape and then I've used it in SolidWorks, or seen it in SolidWorks and then run it in Onshape, or seen it in a Libre. I mean, Ex Machina is in second place here with a time of 4:04 for creating all three of these models. Super impressive. And some really clever stuff that he's doing with a Libre. You know, I dabble in a Libre as well. Some really clever stuff that he's doing here using a Libre to construct these models. So again, even if it's not your CAD that you use primarily, just watching these other people run through these models and kind of thinking to yourself like, wow, that's a clever way of getting that geometry, getting that feature. I wonder if I can do that in my CAD system. And you try it in your CAD system and then you're like, oh, that works great. Like Ex Machina, the way he did it, instead of doing the shell with multi-thickness, he extruded that first extrusion there as a thin feature extrusion. And then later in the model, he does a move face to clean up that extra geometry. So again, just kind of thinking outside the box a little bit, and you know, what I think are very clever solutions to some of these challenges. Using later on in the model here, he's going to use move face to move this over a little bit. I think that's a really clever way of going about that. So shout out to all the people who have competed so far in this challenge, in this TooTallToby leaderboard challenge. TooTallToby.com/leaderboard. If you're not familiar, you can go on there. You can speed model these three parts. You can practice as many times as you want, and then speed model these parts. And right here, we're going to see this move face. He's going to shift these faces in. There it is. Move those in. So cool. I just want to see that again. Anytime somebody uses move face, I think they get bonus points. So here you see he's doing, it's called offset face in a Libre, but basically a move face offset there. Look at that. That's so cool. And then just filleting those edges from the top down. Very, very clever. Very good workflow, and definitely some stuff to learn there, even if a Libre is not your CAD package of choice. So you can see here what this leaderboard looks like currently. There's basically 9 people on it. My run is down here as well. But there's basically 9 people on this leaderboard if you ignore my run. And they are all very, very impressive. There's a Rhino user on here. There's an Onshape user. There's no Fusion 360, no Inventor so far. So I'm going to try and hit up those message boards tomorrow and see if I can't get some of those runners in there. But good stuff on the May leaderboard. Check it out for sure. And of course, the Practice Models app, I mentioned the Practice Models app earlier in the live stream. We've done some updates to the Practice Models app. We've added the country flags of the people who are completing the models. We've added the completion ratio. So now when you are in the Practice Models app here, which means you go to TooTallToby.com/practice, that's where you'll find the Practice Models app. So TooTallToby.com/practice. And once you go to TooTallToby.com/practice, every time you finish one of these challenges, it'll say completed, and you'll get a little color thumbnail of the challenge that you completed. But for the ones you haven't done yet, when you click into them, you can see how many people have successfully completed this challenge. Now, that may be because 173 haven't tried, or it may be because some of them were getting stumped on this challenge. Some of these challenges are harder than others. So it could be that, people are getting stumped on the challenge. When you do complete the challenge, what you'll see is some additional analytics here. You'll see who finished this challenge the fastest. You'll see what your time was. So your time, 4:33. Average time, almost 15 minutes. Fastest time, 1 minute. Wow, that's pretty fast. We do purge the times that are at the very bottom of the curve. If it seems like they're unrealistic, let's say, we do purge those times that are kind of unrealistic, but. Another great app for you to try out. You go over here to TooTallToby.com/practice. You can get in here and you can see all of these different practice models. And if you go to the tab that says Community Scoreboard, then you can see the top of the scoreboard here. One Man Willie from the United Kingdom has 44 models completed. Free CAD user. So 44 models. There are 44 models total currently. So you can see here there are 12 people who have done all 44 of the available models. We just released the newest one, I think, yesterday. So that's pretty impressive considering it's a holiday weekend. People are on it. But lots of people on this completionist board, and lots more good stuff coming in the future with the analytics, but kind of some cool stuff. You can see how you're doing against the rest of the field, and enjoy those practice models. Get them, like I said, get them while they're hot. So huge shout out to Bodie McBoatpants, who's really been working hard on the website, getting some of these tools in place, getting some of these cool analytics up for everybody. Check it out, TooTallToby.com/practice for that functionality. And the YouTube channel has mainly been practice models. I haven't really had much time to post additional new tips and tricks, but there is more content coming, so be on the lookout. Of course, we did post a video recently on the YouTube channel reminding people what the check your system function does. The check your system is actually a song, so if you want to check that out, if you haven't heard it before, check it out. It's a great song. Check your system. It reminds you what the SolidWorks tool does. We also have some videos that have been posted, some more practice models. I made a video called turn off these settings, 3 settings that I always tell my students to turn off to look out for in SolidWorks. We've got a video here on branch and merge that I talked about earlier, and then the rest of these are just practice models and then my May leaderboard. So haven't had too many new power moves type videos going up. Of course, we do have the shorts that go up every single day, and all of those are like power moves. But most of the stuff has been just kind of like practice models. I have been filming. I have been in the studio, so you're going to see more practice moves and tips and tricks type videos coming out this week and next week. But of course, the shorts come out every day. We've been doing a new short every single day since January 17th, except for there was one single day that I missed, and I made up for it early the following morning. So just about every single day since January 17th. And of course, there is a TooTallToby Discord. We are continuing to try to nurture that and grow that. Check it out if you're not in there yet. It's kind of in beta still, but the link for that Discord is down below in this video description. All right, and don't forget about the practice models. We talked about that already a little bit, but we'll have some new practice models later this week. We try to do 9 every month. I think we're on 5 so far for May, so we're going to finish out the month of May, and we're going to get you guys some more practice models before the month ends. You can visit TooTallToby.com just TooTallToby.com if you want to sign up for a free account. Some good stuff on there, and that is it for now. Don't forget, guys, like and subscribe. That's the best way to support the channel. And let's take a look at this first challenge here, this first model. So it looks like we have a couple extra minutes. Maybe I'll just go through and create this model here using SolidWorks. So, you know, whenever you're trying to create a 3D CAD model, you always want to start out by kind of coming up with a game plan. If I was looking at this model here, I think my game plan would be to start probably looking down on the top here, kind of create this sketch here, looking down on it as a footprint. And then I would start to address these little legs that are sticking out here. The leg is sticking out with some draft, but it also has a fillet on top. So, you know, I'm pretty comfortable using the draft feature in SolidWorks. So I would probably opt to just create that as like a half tombstone or a tombstone shape, and then I would draft it afterwards. And then I would go in and create maybe this circular extrusion sticking out. I would just model half of the model. I wouldn't do the whole thing. And then I would, when I'm done modeling half the model, I would just mirror the whole thing. So that's kind of like a game plan. Like I said, we do have an extra couple of minutes tonight here. We're running a little ahead of schedule, so maybe I'll just kind of blast through this one, and you guys can tell me what you think about this when we're done. So I'll start out by grabbing a screenshot. Let's get into SolidWorks here. New. This is going to be a part using, what is this thing in? 1060 aluminum. Now let's stick to the game plan here. Always good to come up with a game plan. Try to stick to that game plan, but of course, if you want to deviate, that's totally cool. You totally can deviate. So top plane, begin a sketch, orient the view, and I'm going to start out here by coming over with a line at 40 millimeters, come down in this direction with a line at 22 millimeters, come over this way a smidge, come back, touch that endpoint, come off of that endpoint with a tangent arc. We'll come out this way, come back, touch the endpoint, come out this way. This one's going to have an arc of a radius 12. I meant to put that radius in on the other one too. That was just kind of a misclick. And then we'll end up vertical to the origin. There we go. Let's make sure that these guys are tangent by clicking the endpoint in between them. Make sure that's vertical, horizontal. Let's add a dimension here. That's my radius of 8. And then we'll add a dimension from here across to the center. And that's going to be my 55/2. Final dimension here is going to be from the very back of the part to the very front of the part. And that is going to be a dimension of 45. And then maybe I'll add in that slot just in this sketch. I'm only going to be creating half of the model, but let's add in a slot here. And I think this one, if my math is correct, this distance here is, let's see, it's 31. So yeah, 15.5/2. The width of that slot is 10. And then the distance of the slot to the front is 12. So it's just kind of centered on that arc, but I'll add in the dimensions anyway, just to make sure. Now let's turn that into an extrusion. We'll grab just this contour. That's going to go to a depth of 14, and we'll do a reverse direction. And there we go. And now I'm going to go back here to this backside, begin a sketch, and I'm going to create that tombstone shape. So start by sketching a vertical line, come back, touch the endpoint, come around. Let's give that a radius of 9. And then we'll come around this way and close that. And then that is going to be located relative to the top of the part, down to that center point there at 35. And we could include the hole in this sketch, or we could do the hole as a separate sketch. I mean, since we're trying to go for time here, it probably makes sense to include the hole there. That's going to go to a depth of 14 as well. There we go. Now we can click on this face and add some draft. So that's going to become our neutral plane. That's our drafted face. And then that draft angle is 14 degrees. Lots of 14s in this model, huh? And then we could pick this face here, begin a sketch, take this edge here, do a convert, and then turn that into an extrusion. It's going to be a thin feature extrusion with a wall thickness of, what is it, 14, 10, 2. Wall thickness of 2. And then reverse direction, also 14. Very convenient. That one's going to go to 14 as well. I like it when it works out like that. And then I think I've got one more fillet here. So we'll do a fillet on this edge with a radius of 10. And then pick this face, expand this menu, hold control, pick the solid body, let go of control. And then we map the mirror command to our context toolbar. So that lets us quickly mirror everything. And then we can do the final spin. Looks like there's one more feature I forgot to acknowledge. We've got like another tombstone shape here, or a slot shape. A lot of times if you have that tombstone shape, you can do a slot and just kind of have some hanging off the end. So that's going to be a slot. The width of this thing, or the radius of this thing, is radius 8. And then the distance to the peak of the arc. So you pick this curve here, or this line, the edge here, hold shift, and then pick the peak of the arc. And then that'll give you that dimension to the peak. So you don't have to like go back and modify the leader or do the math. I guess you could also just dimension it to here at 10, right? No, it's not really that difficult of math. So then that's going to be an extrude cut, right mouse button through all, right mouse button. And now we can do the final spin. And I think that looks pretty good. Maybe I'll go over here to my appearances, plastic, high gloss. Let's add a blue color there. Okay, now that looks good. And then we'll go over here to our sensors. Well, let's see if there's anybody else coming in. Don't think there's anybody else coming in right now. So sensors looks like 117 grams. So I'll get in there in the chat as well and type in that 117. And let's take a look here. What do we got? Latch lock tier 4. Bob in the chat came in with 117. TooTallToby in the chat came in with 117, and the correct answer is 117 grams. Yes. So GG to Bob Phelps. Well done, my friend. Congratulations. You have earned a point on the Model Monday Live leaderboard for May 2024. Very nicely done. Guys, give Bob a GG in the chat. That was awesome. And of course, anybody else who's out there who's trying it, who got it, congratulations. If you're just trying it, congratulations. And if you're watching the recording and you're trying it in the recording and you got it, congratulations to you as well. Alrighty, let's move on to our next challenge. Challenge number 2. See, there's 22 people in the chat. We're picking up some steam on this episode, this late live episode of Model Monday Live. So hope you guys are all enjoying yourselves. If you're just coming in, congratulations. You're just in time for this next challenge. So let's flip over to full screen here. And this next challenge begins in 3, 2, 1, go. What is the mass of this part in XXXX grams? The tolerance is plus or minus 2. So here you see kind of an interesting part. I kind of like this part. It's called pipe mount with hex. So you'll notice that on the one side, you've got those hex cutouts, and on the other side, it's more of a C-bore cutout. You also notice that the 12 through hole and the 20 diameter that's kind of sticking up from that through hole, those are only in 4 places. So that does not propagate around the entire model. So a little bit of a tricky model. Tier 5 model. A lot of features in this thing. You're going to have to up your game a little bit. So good luck to everybody on this challenge, this 3D CAD challenge. Don't forget, if you guys are watching and enjoying this type of content, be sure to hit the like button. Try to get as many likes as we can while we're watching live. And this model is a tier 5 model, a little bit more of a complicated model. It's going to require a few extra features to get this one done and to get it correct. So grab a screen capture of what you see on the screen right now, move it over onto your second monitor, and give this thing a try. This part is centered, so anything that's called out that's not called out as centered, like the ribs or like that slot, they're centered. Everything's centered on this thing. So I know I missed a couple dimensions on this one. I didn't actually QC this one. I think I got most of the dimensions that we need are in there, but it is possible that I missed 1 or 2, and you just have to kind of assume that it's not really meant to be tricky. This one, I ran out of time. It's really the long and the short of it. Carlos is here, says hello from Brazil. Hello, my friend. Welcome. Thank you so much for joining us. Welcome, welcome. Ramex Star says, as an engineering student, I love your tips. It saves me so much time. That is great to hear. Great to know. I'm very glad to hear that is helpful, Ramex. Thank you for the feedback. Hope you're enjoying all the tips. Trying to put out shorts every day to help students like yourself as they are maybe winding down on SolidWorks, getting ready to move over into Onshape. It's a good time to learn some fundamentals, some tips and tricks. And soon we're going to see a lot more shorts and tips and tricks on Onshape as I continue to make my journey into expert level for Onshape. So got a lot of stuff queued up for you on that front. Trying to get out as much SolidWorks stuff as I can and then switch over, get everybody all the Onshape stuff they need to. I know there's a lot of people that are moving from SolidWorks to Onshape, so try and make sure we take care of all those people too. All right, guys. Well, good luck on this model. This is a tricky model. Jern is in the chat, says 117 grams running late. Jern, you got it. GG. That is correct. 117 is that first model. All right, guys, we're going to do a little bit more 3D modeling in SolidWorks here. You saw that live solve a moment ago on that latch lock. Now, let's take a look at this guy here, the stand base 3. This is one that we had a few weeks ago on the live stream as a challenge for the chat. We also posted it as a practice model, and I had a lot of people in the chat asking for advice, particularly on the area of the ribs. Now, this week, I did record a video on how to address this issue with these ribs. I know the ribs in this model are a little tricky, and so I did record a video this week kind of showing how to address that. So be on the lookout. I'm just finishing up editing it. It'll release a little later this week. So you may hear me during this live solve referring to the video, explaining the ribs, and that's just because it'll provide continuity when we release this chopped video on the channel and give people a reference to those ribs. So let's get into it here. A SolidWorks 3D modeling live solve tutorial on a pretty tricky part, the stand base 3, a tier 5 part. And you can see there's a lot of Toby, what we call Toby notes on this part. The ribs touch the circular bosses at tangent. Ribs start and end the same height as the circular bosses. And the ribs are centered on the center line. And the rib is touching off tangent to this radius here of the arc, kind of running up this left side here. So these are the first things you want to look at, kind of any notes in the model, and then you want to get into your game plan for the model. And the game plan always starts with what is going to be my starting plane, what is going to be my starting profile. So my starting plane for this model is going to be the top plane. My starting profile is going to be this main sketch of the triangle. And if you're ever not sure what to use as a starting plane, starting profile, it's always good to just pick the footprint of the model. However the thing is going to lay on the table or mount to the next part, that's always a good choice of a starting plane, starting profile. So you could always go with that. You could always kind of use that as like an anchor and a good way to kind of make sure that you're making a good decision for your starting plane, starting profile. Next thing is going to be, is there any other geometry we want to include in that original sketch? And as CAD software gets more and more mature, it's often very beneficial to include additional sketches in that first sketch or additional profiles. So I'll probably include all the profiles that I just sketched in red there in that very first sketch. Just include all of them, and then that way I'll be able to continue to extrude from that one single sketch. So my first sketch is actually going to look like this, and that should be the first step of your game plan, is deciding kind of what that first sketch is going to look like. Then you want to start thinking about what your features are going to look like. So my first feature is going to be this extrusion of this triangular shape. My next feature is going to be this extrusion of this 12mm height boss, then this 14mm height boss, then the 16mm height boss, and then this 33mm height boss. So now I've got those, first 3-4 features in place. Maybe I'll save that hole that's going through the center for last. It's usually good to save those types of holes until the end of the model. So now I've got, kind of the basic game plan for the initial features. Now it's going to come time to creating the ribs, and creating the ribs is going to kind of be its own little beast, its own little monster. And we do have another video on the channel talking specifically about the ribs. So if that is the main area you're running into a challenge, go ahead and check out that video. But if you want to see the entire live solve for this part, here we go. Let's get into it. This is how we do it. So I'm going to start out with a screen grab of this part. Grab this whole part here, and I'm going to move this part over here onto the other screen, my second screen, so that I can use the dimensions from that part as I'm modeling. And let's take a look at SolidWorks, begin a new part. This part's going to be in plain carbon steel. And we're going to go top plane, begin a sketch, orient our view, and we're going to create the geometry for that triangle. So it looks like it's going to come over here. We're going to have a radius of, what is the radius here? Radius of 12. Then we're going to kind of come up at an angle, come back, touch that endpoint, radius of 12. Very useful to learn how to use that line into arc tangency and then how to auto dimension those radii along the way. That'll be really helpful too. Now we can take this point and this point, bring them together, take these two, make sure that they are tangent. We could probably get rid of these radius dimensions and then hold control and select all three of these and make them equal. And then we're going to add our holes that are in the, or our circles that are in the center here. So this one is going to have a diameter of 50, and this is going to have a through diameter of 33. We're going to have our circle here, which is just going to kind of match up with the existing radius of 12 there. And now we're ready to add in some locating dimensions for this thing. So it looks like it is 65 over to this corner. And it looks like it is 150 from boss to boss in this direction. And it looks like it is an angle dimension here of 35, an angle dimension here of 55, and then a distance from the center of this circle down to this line of 37. And there we go. Nice black sketch. Always what we're hoping for when we're working in SolidWorks. So now we're going to turn that into an extrusion for the base. The base has a height of 8 millimeters, and the contour that we're going to use for this is going to be this contour here. And look at that. There is our base. Now we're going to show that contour. Now remember, in SolidWorks, a good tip is that you can right mouse button on a sketch and you can choose sketch color. And so we could change this to a different sketch color to make it kind of pop out a little bit, make it a little easier to select and select and select. And so now we could go S key, extrude, pick that circle, and bring that up to a height of 12. Enter, enter. And if you press enter again, takes you back into the extrude command. Pick another circle. That's going to be 14. Enter, enter, enter. Pick this circle here, where that's going to be 16. Enter, enter. And look at that. We got all three of those bosses. We could even press enter one more time and pick this guy here, 33. Enter, enter. And that's a pretty fast way to get through those multiple extrusions from one single sketch. So now that we've got those extrusions in place, now we are ready to start talking about the rib command in SolidWorks. And I have made a separate video about this. I'll include a link to that video. But the main thing that catches people with the rib command on this model is the idea that a rib is an extrusion that goes up to next in 3 different directions. So let's start out first of all by creating the rib plane. So the rib plane for this thing, let me just make this a different color here. The rib plane for this thing is going to be created by going to View, Temporary Axes. And once we go View Temporary Axes, we can pick an axis here, we can pick an axis here, and we can use those axes to construct the plane. So we're going to go Reference Geometry Plane, we're going to pick this axis, we're going to pick this axis, and there we go. Now we've created a plane. Now, on that plane, we're going to create a sketch of a line, and we're just going to drop in a line right here just for sake of illustration for this live solve, and then we're going to go to the command Features Rib. Now, what does the rib command do here in this scenario? Well, what the rib command does is it extrudes up to next in this direction, and up to next in this direction, and up to next going down into the model. So when we hit the green check mark, that sketch line extrudes in all 3 of those directions. It's up to next in 3 different directions. And that works great when the extrusion can terminate. But when the customer says to us, I want you to create a brace that goes from this tangency point down to this tangency point, things get a little bit more dicey. Now, to calculate that tangency point on each of these bosses, we're going to use what's called the Pierce constraint. And the Pierce constraint is a relationship that exists where this curve here, the circular curve of the cylinder, passes through this plane. So if you imagine that intersecting point is probably like right about here. Wherever that curve is passing through that plane, that's what's called a pierce point. And what we're going to be doing is we're going to be relocating this point here down to that pierce location. That's what a pierce relationship is. So if we choose this curve here and then we hold control and we choose this point and we let go of control, then what we can see is we can add what's called pierce, make pierce, or over here, pierce, and that point is going to move to the location where this curve is passing through this plane. So pierce. And then I'm going to do the same thing up here. Pick the curve, hold control, pick this point, let go of control, and I'm going to choose pierce. Now, when we try to create the rib here, it fails. So we go rib, and this is supposed to be 7 millimeters in width. And SolidWorks says the resulting rib did not intersect the existing model. So if you think about it, what the rib is trying to do is it's trying to go up to next in 3 directions. It's trying to go up to next in this direction, it's trying to go up to next in this direction, and it's trying to go up to next in this direction. So one of those 3 up to next conditions cannot be solved. And so what we can do to visualize this problem is we could do a thin feature extrusion. So let's say we do a thin feature extrusion here. We make this, oops, sorry, we do a thin feature extrusion here, and we make this 7 for the thin feature, and we make it mid-plane. Oh, I'm sorry, make it mid-plane here. Make it 7 there as well. If we look at this, you know, pseudo rib that we're constructing here, and we look at it kind of dead on normal to or perpendicular to the rib itself, what you'll see here is that there's a little sliver of the rib that's kind of peeking up over this edge. It's a little sliver here, a little triangle, little sliver that's peeking up over that cylindrical edge. So you got the cylindrical edge here, and then you've got this little sliver that's sticking up over that cylindrical edge and this little sliver here. And that little sliver is the problem. See, when we go to construct this rib, that little sliver there, it doesn't have any, there's nowhere for it to terminate. When you try to go up to next, SolidWorks is like, I don't know where you want me to go with this thing. This just keeps going forever because that little sliver is like peeking up over that edge. And so that's why this is failing. And so there's 2 solutions here. Solution 1 is we could just drop in a little flat spot on the rib, and then we could go rib, and this is going to be 7. And boom, look at that. The rib solves, no problem. Pretty sweet. The problem is that we end up with this kind of like stepped area here. And sometimes if you show that to the customer will say, that's not what I want. Like, that doesn't look right. There shouldn't be a little step there. So what we could do instead of that, what we could do is instead of piercing this here, we could figure out what the distance is back onto that cylinder face where that 7 millimeters would be perfectly intersecting. So we could draw a line here at 7 millimeters, and then if we go to a top view looking down, whoops, let me show that plane again. If we show a top view looking down on that 7 millimeter line, we could take that line, hold control, pick our plane, let go of control, and we could say make perpendicular. So now we've got that 7 millimeter line and it's perpendicular to our plane. And then we could take this end point of the line and put it on this edge. And we could take this end point of the line and put it on this edge. And so now our rib will be constructed going from this point over to this point on that little 7 millimeter line that we just created. And so now when we roll forward to the rib, to the rib sketch, I should say. So when we roll forward here to the rib sketch, now we could make this pierce relationship not to the arc, but instead we could make it to this line here. So we could say, I want this point to connect to where that line passes through the sketch plane, which is really the midpoint of the line. You could do midpoint coincident as well. That's not really the point. Pierce is not the point in this scenario. The point is that now we can construct that rib and it's going to end up looking something like this. Now, the problem is that we kind of have this little like sliver of material here, and the customer certainly is not going to want that either. But in most CAD packages at this point, you could use a command like insert face delete, and then you could choose that face there and you could say delete and patch, and then you could hit the check mark and look at that. Now that area is cleaned up and you got yourself a real nice patch area there. So that's the rib in a nutshell. Whenever you're trying to create a rib and you're trying to go up to a tangency point, like in an upward slope, and you're trying to go up to a tangency point on a cylinder, you're going to potentially run into this issue. And the easiest solution is just to draw a little flat spot on the rib, and then it will be able to extrude up to next in all 3 directions. But if you don't do that, then the rib's not going to know where to terminate in this direction. It's not going to have anything to terminate on. So I hope that all makes sense. If it does, put a 1 in the chat. Let me go back to the customer print here and see what they're asking for. So it looks like on the customer print in the detail view here, it looks like they are asking for that little extra bit of material. And also in this view here, it looks like they are asking for that extra little bit of material. So the customer actually does want that for some reason. I don't know why they want that, but that's okay. Whatever they want, you know, it's not up to me. My job is just to give them the geometry that they are asking for. So we'll take this and we will pierce it here, and we'll leave that extra little flat spot on there, and that's going to construct that rib. Thank you very much, Jern, for the 1 in the chat. Glad that was helpful. Let me do this again here. Reference geometry plane. We'll make another plane here for our second rib, and I'll just press enter to repeat that command again. Reference geometry plane, and we will select this angle or this axis and this axis here. Now we have our 3 planes for our ribs. Now we're going to just basically rinse and repeat. So a line here that comes up, a little tiny flat spot. Take this and pierce it to the cylindrical edge. Pierce. Take this and pierce it to the cylindrical edge. Pierce. And then we will do the features rib. This has no problem extruding up to next in all 3 directions now. So it extrudes up to next down here. You know, we show this to the customer and they're like, yeah, that's fine. Don't worry about it. We can deal with that. That's fine. That's what we wanted. We want it to be touching here at tangency. So that's good. And then we can repeat again to over here. Select this plane, begin a sketch, draw a little flat spot here, pick this point, hold control, pick this curve, pierce, pick this point, hold control, pick this pierce, and the rib width, the rib width in the MML number 2 is missing. Oh, great. Thank you. Let's see. The rib width is, I think it's 8. I think no, it is missing, and it is, it's 6. Thank you. Sorry, guys. This guy here is 6. Yeah, assume the rib is 6. QWERTY CA in the chat. We were just talking about him earlier. Wow. Welcome, welcome. Great to see you in here. Great to see you in here. Welcome. Thanks for joining us. Think we're missing a dimension there. I do apologize, everybody. It does happen. We're going to call that 6. I'll confirm. Bob coming in with an answer, 2366. I like it. I like it. I like it. Good job, everybody. Thanks, man. I love your content. Thank you. I love your content as well. So that's very nice of you to say. All right, so finishing this thing out here, we got this rib. Let's go features rib, and we're going to make that 7. And there we go. And then here's kind of a cool trick that you can do. This is a hole wizard hole that's being called out on this print. It's being called out in 3 places. So that hole wizard hole is 3x 9 through 16 by 7, 16 counterbore diameter by 7 deep. So what we could do here is we could go hole wizard without pre-selecting a face, and then we can come down here to the custom sizing. So this is going to be 9 through 16, 7. So I'm using the tab key to advance through there. And then we can go to positions, and now we can choose 3D sketch, choose this button here, 3D sketch. And then that will let you actually make all 3 of these in one shot because you're doing it as a 3D sketch. And if you hold your cursor over the edge of that cylinder, then you can wake up the center point of that cylinder for each of those 3. So kind of cool how you can get all 3 of those holes in one single hole wizard if you know the trick, which is when you begin the hole wizard, pick your size, go to positions, and then click this button here for 3D sketch. And that'll let you drop a 3D sketch of those points on at the 3 different heights instead of doing it in a 2D sketch and having to do hole wizard, hole wizard, hole wizard 3 different times. So kind of a cool little shortcut that you can use there. And so now we're going to finish this up by doing an extrude cut. That's going to be from this circle here, reverse direction. It's going to go through all or 33. And then we can do the final spin, look this thing over, and take a look at our sensor and rebuild here. And the answer we're coming up with is 893 grams. And if we go back to the PowerPoint, let's see, did we get it right? 893 grams. Oh, yeah. Let's go. So that's your SolidWorks tutorial, SolidWorks live solve for that stand base 3. It is a tier 5 part. There's some trickiness in it. I think the biggest tricky part is the rib. And so that's why we made a special video just for that. But there's some other cool stuff there in that challenge. And I hope you guys enjoyed that. And that's going to bring us to the end of the hour. We are winding down here on this episode of Model Monday Live, Model Monday Live Late. Nice to see some new names in here tonight. Maybe if this gets popular enough, we could do 2 shows on Monday. We could do an afternoon show and a nighttime show. But let's see how we did with our answer here. Don't forget, guys, if you enjoy this type of content, be sure to support the channel. We do a lot of fun stuff on the channel, a lot of fun stuff at TooTallToby.com. The only way it keeps going is with support from users like you. So like and subscribe, share and reshare. And of course, the value for value proposition. If you feel like you're getting a lot of value, send some value back our way. Peter is in the chat. What's up, my man? Thanks for joining us. Petar. Welcome, welcome. Thanks for joining us. You can visit TooTallToby.com/donate. You want to be like this guy, you can use a super chat. You can use the website, TooTallToby.com/donate. We do very much appreciate all of the financial support we get from our fans and from our super fans. So thank you so much. Harv says, thanks, T3. Thank you, Harv. Good seeing you tonight. Thanks for joining us. Pitar says, greetings from Serbia. Yo, let's go. That is awesome. Riley's here. What's up, Riley? Hello, hello. Welcome, welcome. Don't forget to check out all the apps, especially the Practice Models app at TooTallToby.com and the Leaderboard app. And the tournament is coming up soon, guys. June 17th, registration for the tournament opens. So check it out. Let's get into our answer here from number 2. Did we guess the correct width for the rib? 2336. Let's go, Bob. Clean sweep. Wow. Congratulations. That is awesome. Good job, man. Bob getting in there with a clean sweep tonight. Representing Iowa. That is awesome. 2 for 2. Congratulations, congratulations. Yeah, GG, Bob. Well done. And was that rib 6? Let's just confirm. Don't forget, guys, the quickest way to measure something in SolidWorks, just pick one face, hold control, pick another face, and then look down here in the status bar, and it will tell you what the distance is between those faces. So, yes, it was indeed 6. We did it. Nice. Bob, great job. GG. GG to Bob. Clean sweep tonight. 2 points on the board. Well done. Closing out May with a huge win. Congratulations to our winner. And thank you all so much to the most amazing chat ever. You guys are awesome. It's great hanging out with you on this Model Monday Live night. What a great way to end a nice long weekend. I had a great weekend, great long weekend. I'm excited to get back to work this week. So good luck to everybody this week. Don't forget, your challenge for the week is to tell one coworker about the channel. Very important to tell one coworker. Don't forget, if you're getting ready to make the switch to Onshape, check out the tutorial that I posted. It's a full step-by-step tutorial. You can, even if you're not ready to get the paid version of Onshape yet, you can run this using onshape.com/free, the totally free version of Onshape. So you can go through and you can model this Sterling engine. There's a PDF guidebook with all the sketches and all the dimensions and everything we use. And it gives you a good chance to get some exposure to your next CAD system, potentially. So check it out. And I want to say thank you all so much for being a part of this. Next week, May 3rd, we are looking forward to some more live CAD versus CAD action. In the meantime, this week, don't forget, if you see anything posted this week, practice models, shorts, social media, text, image-based posts, be sure to like, be sure to subscribe, be sure to share, send it around to all your accounts, send it around to everybody in your family. Say, hey, open this up, watch this video, watch the whole thing, like it, and let's do whatever we can to keep these numbers growing for the channel, and have your friends send it to their friends, and have their friends send it to their friends. And, of course, I want to thank you all so much for being a part of this. It's a lot of fun seeing everybody in here tonight. So that's going to do it for this episode of Model Monday Live. Guys, let me know down in the comments what you think about this time slot, if you think we should do it again on this late time slot. And huge congratulations again to Bob for sweeping tonight. Awesome job. And I look forward to seeing everybody throughout the week in the videos, in the chat, in the comments, in Discord. And I will see everybody live next week on Model Monday Live. Have a great night. Have a great week, everybody. Enjoy the rest of your Monday.